In this project, we're going to write to our SD card. So we've got our maker, Wi-Fi 1010. We've got our ENV shield. We've got our SD card and an adapter. And we've got a reader. So this will let us connect our card to a computer. This is a multi-interface reader that we can connect to a laptop. And all we have to do is slot our card into our shield, our ENV shield. And that's it. You'll feel it slot in, and then as usual, we attach this and rock it in, and that's it. We're ready to upload our sketch. Once we connect our power. So let's go over to our code. We have our regular include in lines 1 to 4. On line 6, we have our include for our maker ENV shield. On line 7, we include the SPI header file because the SD card reader communicates using SPI. And then on line 8, we have a header file that will let us work with the SD card reader. On line 10, we declare variables that will let us hold temperature and humidity values. On line 11, we define a constant called chip select, which we set to 4. That value is required in order for us to work with the SD card reader using the maker Wi-Fi 1010. And then lines 12 to 13 are something that you should be familiar with by now. It just lets us set a delay, in this case 60 seconds. So we'll take a reading every minute. Then we will declare a variable called status, which we will set to the idle status that indicates the status of our network connection. And then on line 15, we will declare a real-time clock. Within our setup, we'll begin by starting our serial monitor. And then on line 21, we will initialize our ENV shield. And we need this to work. So if initialization fails, we will pause execution. Now on line 26, if we're able to initialize our ENV shield, we can go ahead and initialize our SD card reader. On line 26, we just print out a status debug so we know where we are. On line 27, we call the begin function of the SD card, and we pass in the chip select, which had a value of 4 that we declared earlier. Now, if that doesn't work, we need to print out some debug information for ourselves and then pause execution. However, if we get to line 34, then we were successful in initializing the SD card reader. And that also means that we detected a card. On line 37, we attempt to connect to the Wi-Fi network. And we've gone over that in previous videos. On line 46, we initialize our network time protocol client. And on line 47, we get the Unix time from the internet. On line 48, we pause execution if we were unable to initialize our real-time clock. Within our loop function, line 57 checks for whether the interval between the last time that we took a reading and now exceeds 60 seconds. And if it does, we increment our timer, and then we call a function called readENV, and we'll see that definition further down. And once we call readENV on line 59, on line 60, we print out the temperature value on 60 and 61, and 62 and 63, we print out the humidity value. On lines 64 to 66, we get the string values of the year, the month, and the day. And on line 67, we get the Unix time. On line 68, we call the write TSV to file function, and we pass 4 parameters to it: the year, the month, and the day, as well as the Unix time, which we call epochs. We can see the definition for readenv, and all we're simply doing is calling getTemp and getHumid, 2 functions from the myenv namespace, and we store them in temp and humid. So let's take a look at the myenv header file. In there, we have the myenv namespace, and then we have a few functions. Now, the function that we worked with is the write TSV to file. And what we see in there is that it takes 3 string values, the year, the month, and the day, and we actually use these to construct a folder hierarchy on our card. And then we also have our Unix time. Now, in the C++ file, we can jump down to the bottom and take a look at our definition of write TSV to file. That starts on line 47. And we can see that we're passing in our year, month, and day values as strings, as well as a Unix time. Within the function on line 48, we open our SD card, and then we create a string, and we carry out a bunch of concatenations. But you'll notice that on line 49, the first value there is a front slash. And in directory structure, that takes us to the root folder. Then on line 50, we concatenate the value of the year. On line 51, we concatenate a front slash. And on line 52, we concatenate the month. And then on line 43, we check whether that directory structure exists on the card. On line 54, if that structure doesn't exist, we go ahead and create it. So basically what we're doing is creating a directory structure of year and month. And then on line 56, we again concatenate a front slash to that string F. And on line 57, we concatenate the day. And on line 58, we concatenate a file extension. So now we have a folder structure with a file name and an extension. Our extension is TSV. And TSV is short for tab separated values. Then on line 60, we open a handle to that file, and we open it such that we can write to it. On line 61, if that operation was successful, we then write into that file using the printline function on line 62. And what we write in is the result of a function called getTSVReadings. And we'll go back and take a look at what getTSVReadings does. And once we write our value in there, we close our file. Now, let's jump back to line 38 and look at the definition for getTSVReadings. It's a function that returns a string. It takes a Unix time as a parameter. And on line 39, we construct a new string with that Unix time that we got as a parameter. And then on line 40, we concatenate a tab space to that string. On line 41, we get our temperature reading and concatenate it. On line 42, we concatenate another tab space. On line 43, we concatenate our humidity reading, and then we return all of that as a string. GetTemp and getHumid are defined further up in the file, and you can go take a look at them. Okay, so we're back here, and all you have to do is make sure that you've updated your Arduino secrets with your Wi-Fi credentials, and then you can upload the sketch. Let's go ahead and try that now. Our file is done uploading, so we'll open our serial monitor and wait a bit. Okay, and after waiting a little bit, we can now see our temperature and our humidity being printed out to the serial monitor. Now, this will also get written to our SD card, but we have to wait a few minutes to get a few values in. So if you're following along, you can wait a few minutes for your microcontroller to write values into the SD card. I'll pause the recording and then come back after a few minutes and show you what we have, and then open up the SD card and show you what we have on the SD card. I've waited a few minutes now, so I will turn off the microcontroller, take out the SD card, and connect it to this computer, and let's see what we have on the card. I've plugged in the card, and we can see that, as expected, we have a folder which is named after the current year, which is 2023. That's when this video is being recorded. And if we go in, we have another folder which is named after the current month, which is October. And if we go in there, we have a file with today's date, which for me is the 16th, and then the .tsv extension, which is what we saw in our Arduino sketch. And we can go ahead and open this. And it's been opened with a spreadsheet application on a Mac operating system. You can still go ahead and open it up with something like a regular text reader, such as TextEdit. And I'll just drag it over from another screen. And there we have it. Here's our timestamp. Here's our tab space. Here's our temperature, our tab space, and our humidity. And there we have it. We've successfully stored data on an SD card, and we're reading it back out on a computer. Let's confirm that we have an SSH key. And if we don't, we can go ahead and generate one. So the first thing we need to do is open a terminal window. I'll drag one over from, so I'm already in my home directory, but just in case, this command will take me back to my home directory. And all I need to do is look for the contents of a hidden folder called .ssh, and I'll use the list command for that. And in this case, we can see that I have keys. If I didn't, I would go ahead and generate new keys. And the command for that is ssh keygen. And I want RSA encryption. And my key length will be 4096. And that's it. I'll just hit enter and I'll get new keys. Let's learn to set up Ubuntu server on a Raspberry Pi. I've got two different Raspberry Pi models. This is our card holder with a card in it, an adapter, and this will let us connect the adapter to a computer. This is a Raspberry Pi 3 model, and this is a Raspberry Pi 4 model. There are two types of the Raspberry Pi 3. This particular one that I have only has a Wi-Fi module. It doesn't have an Ethernet adapter. So it's useful for lab purposes. This has an Ethernet adapter, and you can see that here. So it's useful for remote deployments. This is only useful for use where there's Wi-Fi. So for the purposes of training, it's fine. Both of them require the use of an SD card. This already has an SD card installed right here. This doesn't. This is the port, but I've taken it out. And this is the SD card. I'll use the 32 gigabyte model. So we're going to install the OS over on our computer. So let's go do that right away. In order to install an OS for the Raspberry Pi, you're going to need to make use of the Raspberry Pi imager. And you can go to this website, raspberrypi.com, and then go to the software tab. And from there, you'll be able to download Raspberry Pi imager for your operating system. I already have it installed, so I'll just go ahead and launch it. Now, once you have Raspberry Pi imager open, you can go ahead and choose the operating system that you want to make use of, and also choose the storage location, and then you can go ahead and write the OS onto the SD card. So remember that we're making use of the SD card, and you need to connect that to your computer. Now, let's go ahead and choose an operating system, and there are multiple approaches to this. You can definitely work with Raspberry Pi OS, but in this instance, we're going to be working with Ubuntu. So what you want to do is go to Other General Purpose OS and click on that, and then you can pick Ubuntu. And then what you want is a server version. You can pick it at 32 or 64-bit. And there's a bit of explanation there. So the 32-bit version is good if you're making use of, let's say, the Raspberry Pi 3 or the 4, but with very limited RAM. And 64-bit version is good if you've got something with more oomph. So 4 gigabytes, 8 gigabytes of RAM. 64-bit version is good. And then the difference between, say, 23.10 and 23.04 is just that the 23.04 has long-term support. So if you're doing any general purpose work, you want to go with the long-term support version of Ubuntu. And you can just take a look. There are other versions such as the Ubuntu Core. There's also the option to use a downloaded version, but just for the purposes of illustrating, I will go ahead and pick one. And then you can choose your storage. So remember, we had a 32 gigabyte SD card, and that's it. You just pick it. Now, before you write, you're going to want to go to Settings. Yeah, I'll take this and do a little bit of work. Let's see if this works. Fine. Now you can go ahead and configure your operating system setup so that you can avoid some post-install work. So for instance, we can set our host name, and I might just want to call this Ubuntu or Ubuntu server. And I will definitely want to enable SSH. Do this, and then I can enable SSH, set my host name. I can set a username and password if I so desire, and LAN has been configured for me. And then I can set my locale settings, Africa, Lagos, keyboard layout, something else, maybe GB. Yeah. And then I can go ahead and save, and then go ahead and write. And that's it. Once this is done, you can take the SD card, plug it into the Raspberry Pi, boot it up, wait a few minutes. If you're using the LAN option, then be sure to plug in the LAN cable, and then take a look at your router or your switch, and you'll see a new device come up, and then you'll know what the IP address is for the Raspberry Pi. And that's all there is to setting up a new Raspberry Pi. Let's connect to our Ubuntu server via SSH. First thing we need to do is open our terminal. I have my terminal window open. And then in the terminal command line, we need to type SSH, the username, @ and then the IP address of the Ubuntu server. If this is your first time of connecting, you'll be asked to generate a key. And all you have to do is type yes. And then you'll be asked for your password. Put in the password and you'll be connected to your Ubuntu server. And there you have it. Let's install the MySQL server and client on the Ubuntu server. We're going to make use of the package manager. So the first thing you want to do is run sudo apt update, as you see on the screen, and that will update the package manager. Wait for the process to complete, and then the next command is sudo apt install mysql-server. You'll get a bunch of information on the screen, and essentially at the end it asks you whether you want to continue. Hit the enter key to choose yes, and the installation will proceed. You'll need to wait a few minutes for that to complete. Once the installation is complete, you'll need to start the MySQL server. So type the command sudo systemctl start mysql.service. And that's it. The MySQL server is now running. Type the following command to log into MySQL as a super user. If this works, you'll get the MySQL prompt. Next, you need to issue the SQL command that instructs the server to change how the root user is authenticated. Type the command that you see on the screen. Next, flush privileges so that this becomes permanent. Then exit the MySQL interface. Back at the prompt, run the MySQL secure installation script. Fill in the root password. Follow the instructions on the screen and wait for the script to complete it. Log into the MySQL client once again. Next, set the authentication for the root user back to the default. And that's it, you're done. Exit the MySQL interface. Begin by logging into MySQL as the root user. Next, create a user. Persist this using flush privileges. Exit. Now try to log in using the newly created user credentials. If this works, you'll be at the MySQL prompt. Exit the MySQL prompt. Log in as the root user once again, and then create a database called telemetry. Grant your newly created user permissions to access the telemetry database and objects. Exit. Log in using the newly created user. Now you should be able to access the telemetry database. Visit the URL shown on the screen. Scroll down to the platform section and choose Ubuntu and Debian. Then copy the script shown. Go to your terminal and ensure that you're logged into your Ubuntu server. Paste the script. Hit enter. Put in your super user password and then wait for the script to complete execution. Next, start InfluxDB using the command shown on the screen. Wait a few seconds. Open up your browser and type in the IP address of the server where you installed InfluxDB. And then you need a port number, and that port number is 8086. Once you're on the page, click on Get Started. And then simply fill in the fields with the values that you'd like. Just make sure that you remember these values. Hit continue when you're done. And that's it. You're in InfluxDB. You can click on continue later and then you can get started.